I will be introducing some of the mathematical concepts that are like even today, whatever you say like machine learning, artificial intelligence algorithms. So they'll be using directly in terms of apps, or sometimes they may be using libraries. But I will try to give you the glimpse of the mathematics behind that particular algorithms. So like before, we will try to understand what is meant by predictive analytics and how mathematics plays an important role in predictive analytics. Slides are full. Yeah, I think before going to my talk, uh, I will. I would like to say Happy National Mathematics Day to all. As the legendary mathematician always says, like an equation means nothing to me, like unless it should express as a thought of God. By motivating this, I will be focusing on some of the mathematics concepts that are useful in the engineering, science, and technology. So my agenda of my today's talk is we will try to understand mathematical foundation of machine learning and artificial intelligence algorithms, uh, and also we'll try to explore the mathematics behind the data science techniques and analytical models. I will also give you the glimpse of how the numerical methods that has been uh, used in various kinds of algorithms that we are using in today's environment, and we will also try to understand the significance of linear algebra. This is the foundation of the computational engine. Let us say, like whatever the things that you do, we have to represent in terms of algebra. Then let us move with the slides, and then like we will try to understand what is meant by mathematics, predictive analytics. What is meant by, we will try to understand what is meant by predictive analytics and how mathematics used for the predictive analytics. Generally, mathematics for predictive analytics will provide a theoretical foundation that enables models to learn from the data and quantify the uncertainty and make a reliable forecast. What does that mean exactly? Generally, what happens is these days, wherever we go, like not only like things wherever we visit and wherever we go, all the things are in terms of data. Maybe it may be sometimes voice data, sometimes video type of data, sometimes audio data, sometimes images, sometimes normal data. So because various places that we visit, we will be getting to know that what kind of data availability. So depending on the data availability, we should decide what kind of algorithm we have to use so that the model can predict effectively. And also here, most of the mathematical concepts behind them actually, like, and we will also see that what predictive analytics is fundamentally. It is going to give us a mathematical machine learning model, and by applying the our mathematical concepts like linear algebra, probability, optimization, calculus, to extract the patterns behind the data. So this is about the predictive analytics. I'm repeating again. Predictive analytics is nothing but we will be getting at the end of the model from the model, means model we will be getting from the data actually. Before data, we'll be having data cleaning, data smoothing, and then we will be going for the model exploration. Once you're done with the model exploration, then we will be predicting the feature. So this is how the structure forms actually in the predictive analytics. Yeah, as you see, the mathematics in everywhere. Like this is the slide that we can confirm. Like you can see, mathematics can be used in various places. Like we can say programming, algorithms, blockchains, data science, AI models, machine learning, signal processing, deep learning, graphics, simulations, cryptography things, and securing things. Whereas when you are developing different kinds of things, in each and every way, like each and every perspective, we are going to use the mathematics. But only thing is the way that we are conveying to the student. So that was very very important actually. So like as the most of these concepts are from the mathematics only, but thing is like we will be giving the mathematical concepts that they are considering as some library, and then they are using as a computer science people. So now you can see the today's the fascinating world, like most of the people are working on machine learning. As I think already other speakers has most on like they have spoke about these things. I think you also got bored about, like I will just give the glimpse of this actually. So machine learning is categorized into three parts: supervised, unsupervised, and reinforcement learning. And thing is like here, what is the difference between these three concepts? Supervised learning means once like we know the output and input, and then we are trying to do the model exploration. Then that is called supervised. Unsupervised modeling is something that we have the some data. We don't know what kind of output we'll be getting, but we just dump the data. From the data, it learn actually. When it give you some model, depending on the model we are getting, then we will try to use the different activate functions so that we can predict the we can for proper model exploration. And in the reinforcement learning is also the similar version, but here minimum somehow in the unsupervised learning we know the this what you call uh, input data. But whereas here you may be having some type of audio file, some image satellite data, those things reinforcement learning you can use, and then from the data itself it will learn the data and then it is going to predict. So these are the main difference between these three concepts actually. And in the supervised, it is not visible. Sorry, we're going back. No. Yeah. So here in the supervised, it is not visible there. Okay, in the supervised learning algorithms, we will be having as data. Sorry, yeah, regression and classification and deep learning algorithms. And the similarly, like unsupervised learning, we will be having the clustering. Why clustering is required actually generally? Sometimes what happens is you may be having the data that is like you cannot going to divide the properly. Like you may be not getting what exactly it is. By making some cluster in the sense by drawing some line in terms of mathematically we will be drawing some lines, whichever the having the most similar data will come one side and others data will go other side. So that way we will be trying to do, because here in the unsupervised model we will make different clusters. From the cluster we will learn, and we can also apply for the each cluster different activity functions to get the exact model exploration. And in supervised, as you know, like regression and classification and deep learning also there. The classification algorithm, as we know, like logistic regression, in an artificial neural networks and decision tree was there. And when we go for the deeper level, we will also have the convolution neural network and recurrent neural networks. So this is about these algorithms. And now, before going to the like, as I mentioned, uh, when we want to have some kind of machine learning model, before that there is a one stage that is very very important: data handling. What happens if you are not handling the data properly, usually in the usual way? Generally, what is going to happen is, if you are not handling data properly, definitely data exploitation takes place. In that scenario, definitely you may face some of the issue. Like you model what you are getting that you may be not getting is not even related to some time. So this kind of issues may come. What is meant by data exploitation? Like why it is data process? What is meant by data processing? Data processing is nothing but simply we can say we will be most of the time we will be seeing the data. Generally, what happens in the early days of the development of machine learning, they just dump the data and then they train and then they try to predict something and then they are having some kind of model and then they're moving with the prediction model. But in the initial days, what happened like they are trying to understand level later on actually. When they do that, whatever the data prediction they are doing, that is not happening. Then again they back to the things. Then why the when you train the model, why we are not getting proper data predictions? Then when they check back to the original data, there are some values are missing values in between the data. But they are not processing that data, and then without that they have they went for the model exploration. So in these scenarios, definitely one
Raju
will
sir,
face. Sorry, ma?
uh, can you make it as a full screen? Participants are like sending messages that they are unable to see the
Oh, okay,
slides.
okay. Okay. Yeah, yeah. This is no.
Thank you, sir.
Yes, I think data handling stage. Sorry. Hmm. So here in the data handling stage, most of the time we will be dealing with either sometime missing values may be there. Sometimes you may be having infinite value something. You have to fill some data so that then only we can go for the next process. Sometimes not only the data, sometimes you may be having the signals also. Like smoothing data will be used only in the signal processing most of the time. Smoothing, why it is required? Sometimes you may be getting some part of signals. If you want to make it smooth, what we have to you have to use some kind of numerical methods to smooth that particular data. Now, what I will try to show you is we will have now. I will show you some answer. Uh, 1 minute. I will show you the some answer session. I need the board. 1 minute. Start sharing. Share without video. I think board is visible, ma. Board is visible now.
No, sir.
Yeah. Now let us say we have the data in such a way. Not visible,
It's
huh?
not visible, sir. No screen is shared.
Not shared. Share the screen. Stop sharing. Went out. Stop presenting. Now it is visible, I think. Now it is loading. Yeah. Now I think whiteboard is visible, right?
Yes, sir.
Yeah. So now uh, let us suppose we will be having the data. Let us say something we may be having one and some missing value one value we have. Now early days, what they are trying to do is they are avoiding this particular missing value, and then they are processing the data. So in this case, without filling this value, if you try to predict the average or whatever the statistical measures, if you try to predict, definitely we will have some error. Rather than that, by using the mathematical concepts, like we know the numerical methods, filling the missing values, filling, right? Like we may be having the interpolation concepts. Whereas we are most of the time we are discussing about interpolation, but we say that where it like missing values we can calculate, but when you show like in this perspective, like in this way, the students also get interested actually. So this one, like there are various ways one can fill this data. One can take the average of the previous values and then they can fill this data. That also depends on the requirement, the industrial requirement or whatever the model exploration requirement we have to decide. Sometimes they will be taking even median also. Median they will take and then they'll fill that value and then they're processing. And sometimes you may be having the data, like as I mentioned, smoothing data, right? Smoothing data is something. Let us say I have data maybe in this way. But I need to have some smoother structure. Or if you are getting confusion with this, like you may be having like this, some structure we have. But actually, we need to get this signal as in this way. So to get this, if you have this kind of data and to get this kind of smoothed signal, we have to apply some of the mathematical concepts so that we can achieve this particular filtering process. If you apply some filtering process in terms of mathematical concepts, then we'll be getting this. I will be implementing this in live session also. And similarly, like this is the way, like before going for the data exploration, one has to do what I'm trying to say is like more, when we have a data should be data pre-processing stage must actually these days. Data pre-processing has to do either sometimes you may be having data cleaning. We'll also call it as filling or filling the missing value. Filling the missing value. And or sometimes you may be you may have to do smoothing the data. Smoothing data is something that I mentioned, like signals and systems. If we take most of the signals, they may be having improper signals. By applying the some filter, like the filters we have backend with the numerical methods, and then they'll be getting the proper signals in this way, smoothed back. Now we will try to implement this. And I will be sharing here. Um, is it visible? I think, right? Start. So now, if you want to implement, you can also implement with me. Like we will be doing with online now. Let us say here. Sorry. Data variable plane. Yeah. I hope screen is visible. And the down, because this is the active online screen. If you want to know how to come here, like you can just go to Google and just type Octave online, and it may ask you sign in with either Google account. If you have, you can just sign in easily. You can sign in it here. Let us say I'm using the MATLAB commands here. We can execute online actually. Clear all. So I'm typing the commands here. The variables are also stored here actually. That you can see here. There are different panes that we have. Yeah. The variables will be stored here. Let us say if I give you a is equal to some 10. The values are stored here. I think you can see the variables, right? And here, if you want a group of codes that we can run here actually. So for the data pre-processing stage, initially what I will do, if you want to know better understanding of data processing, I will try to create some plot. In the plot, some data I will remove. Meaning that let us assume you may be having the data from 0 to 100. Now 20 to 30 I will make discontinue, like without filling the data. And then now by using our well-known mathematical methods, we will fill that data and we will try to understand with the various method how it transforms. I hope you have a clarity, right? I'm making sense. So now you can see here I am just creating some function. Function is equal to I'm generating some data, matrix data. Zeros of 1 comma 5. Zeros of 1 comma 5, what it does is first row 5 entries it is going to give us zeros, comma, and remaining I want to have ones, actually ones of 1 comma 95. So now if you run this, there was an error, extra bracket was there. I think we can, yeah, yeah. Now you can see here there was a generated function here. This is as I mentioned, first column entries, first 5 row in the row, actually one column 1 to 20 values it has been divided, because here 1 to 5 it has taken zeros as rows value, and remaining it has given 1 1 actually. So this is the function that is generated now. Let us try to plot this actually, so that we'll have a clarity. Plot function in the graphical representation, it will have a clarity. See now here we can't see the value, like, right, because ones are there, there are many ones are there. So till here it is 0 till 5, because after that it is started taking value 1 from here till here. So we are not able to see that, but what I will do, I will compress that limits so that we can see actually. While limit, I am going to make it as while limit is till 1 is there. So we can extend that expansion now, so that the value whatever we are trying to have, our target will be in between actually, so that we can look at that value. So now I'm giving y limit is -2, because we have a 0. If it comes some more data here, so that the plot also will come there. So it is visible. It will we can see easily, and we can analyze also easily. So y limit I'm giving -2 to +2. So y limit has been changed. I think you can check it here, right? So that some clarity has come now. But still, I will also change. I think we can x limit also. Can x I am going to limit with 0 to 30. This also okay, fine. If you want to continue with this, we can continue 0 to 30 if you take, and we will have a little more clarity. Now you can see, right, step function has been properly tested. As I mentioned, y values has from 0 as output till 5. After that it is started taking 1 actually, from here 1, right? 6 to 30 all the values are 1. Earlier we have given till 100, but now we have compressed that into within our limit to understand better understand. And then now we will be before that what I will do, I will just generate some missing values. We have to cut the data, right? I will cut start now. So the function from where to where we wanted to cut, let us say 10 to 15 if you want to remove, or 15 to 25, we can say 15 to 25 or 10 to 15, anything equal to, I'm giving NaN. In MATLAB, it take not a number. So now, if you look at this data, I think data has been generated, and again we will plot the function. So if you plot the function, yeah, again we have to apply the same y limit and x limit, both y limit and x limit. Now you can have clarity, right? Now, so what we have done, we created some plot, because you may be having the different kinds of data that you can take up as of your wish. Before going to processing, this is the stage that we have to taken care of actually. Otherwise, the data exploitation takes place, like prediction may go wrong. So now here we have to fill these values, then only we have to go for the model exploration. Without filling, we should not go. So to do that, now to fill that, I am applying the sum of the interpolation concept. Interpolation, you can have someone is equal to the MATLAB. Actually, you can have, you can also check in the help command. So it is directly, it is going to show us like filling, interpolation command, cubic interpolation. There are various commands are already available here. You can just go to the help command and then just try to use like how to use the missing values. So from here only I am getting there. Like I am just using the online sources. I am not creating myself anything. I have just used the whatever the sources are already available. From that we are learning actually. Fill missing. Fill missing is the command to fill in missing values. And here our function, the data name is we have given as a function, and next it has to take whatever, like the, as I mentioned, right, what are the concepts are there that we can check here actually. Let us see, search here, fill missing command. You can see here there are various interpolation methods. You can see there is a constant method, move method, and dimension constant. You can also check here different examples they have given here actually. Even you can also try this also. So now if I try to fill this value with the move mean comma 4, what it is going to give us is, let us see. And again you have to plot, every time you have to plot the function, plot function. Again limit also we have to exit, x limit, y limit. Oh, still it is not filled, I think, right? I think we have to run at a time actually these things. Fill, let us say, oh, okay, because the interpolation that we applied, that was not in function, right? We have stored in INTE or somewhere, I think, right? You can check it actually. Yeah, you can see here we have stored the concept that we applied. Move mean means what it does is it will take previous 4 values average and it is going to fill the next value. Similarly, it is going to move actually average value, averaging of 4 values, previous consecutive 4 values, and then it is going to fill and then it is move on. Sometimes you may be having the previous also, previous values it is going to take and then it is going to fix. That way it will take actually in the numerical methods actually. You may be studying, I think, Newton forward and backward, all those formulas. Similar version only. Now I have to plot INTERP1 actually. Plot of INTERP1 to understand movement. I think it has come. I'll put semicolon because data is generating every time. And X limit also. Still the same either. The reason, okay, let us see once again. Still let us. previous command, let us take interp is equal to interpolation fill missing within brackets function. This is our function, right? Function comma within single quote we have to give within single quote we have to give move mean or previous. We can give move mean comma 4 values I'm taking. So now let's see. Oh, now plot interp. I think we are plotting x limit and y limit. X limit, y limit. I think it is filling one value. Let us I'll fill by using other one actually. We'll also let us take this exam. Let us see. Let us say I have a data in this way. We'll use the same commands here. So that f is equal to fill missing. Okay, I have put semicolon like yeah. So what it has taken is you can check here. We have the values a values as 1 3. There is no number, and again number. There is no number. There is no number. Sum. So previous command it is going to take the previous value and then it is filling. So NAN previous value is 3, so it has filled 3 here. Here also previous value is 4, it has filled 4. Similarly here also. In the same way we can also use instead of this move mean actually. Let us see. Okay, we have to give some value also. Average value of 2. Let us take. I think for this we do not have 2 values in the next right side, so that still it has given the same NAN actually. So here what it does is it is taking the average of the previous values and then it is filled actually the 2 values, right? Similarly here also and here also. So that's how like it is going to take the average and then it will move. Now I think the same function in the plot it is not. Next let us say f is equal to we will see here itself in the plot. I think original data is this. We have some command here, you can check here. This is the signal median. I will try to implement for the next one. Actually we have to copy this. Let us. I'll be filling this move mean at a time. Let us run the program and give the proper semicolon and here also. Okay, now let us check the output what we are getting. This is happening, this is okay. So we have cut the data from 15 to 25. Data might be not there more. Let us see only 15 to 20 missing value. Once again just plot the command plot function plot in NTR. Still missing values, okay, but still getting the same output. Fine, I will try with the signal. I think smoothing may work actually, definitely. We will also see some signal actually. There also the similar concept will apply. Let us see. T is equal to, let us assume 0 to, I am taking some step length as 0.1 to some pi. Because I am generating the value from 0 to pi, some with a variation of 0.1. So it is going to generate now. It is generated, but because I have terminated with a semicolon, so it is not displaying here. So similarly, I am creating some signal. Signal is equal to cos of, because we will be having in terms of waves, right? So 2 pi t, because we have defined t there, 2 pi t. So now, yeah, oh, cons, there was a spelling mistake. CYS cos actually. So now it is generated. And now if you try to plot signal, plot SIG, so it has been generated signal. Now for I is equal to 1 to, I am generating the loop actually. So for this loop, let us try I equal to 1, length of it has to run till where, what the length of the signal. So whatever the length of the signal is, that till that it has to run. So length of the signal. Then actually when you try to look, I think I am just copying here. I think I will explain here. Because it look for end statement. And then I will explain. So now you can see here, what we are trying to do is we are generated some signal. That signal we will be taking till it has to run for a continuous mode. And the same way, like as I mentioned in the previously, similarly I will cut the data middle. Somewhere you will be getting here without having that closed smoothness actually. So to do that, what I am trying to, I am using the if by applying the some condition from 0.2 to 0.6, I am cutting the signal. It has to generate and not a number. So let us see that. So it has been generated. Now we have to plot plot signal, updated signal. You could see here. Certainly more advertisements are here. TLOT plot such a signal. Otherwise they can run in the recently not working. Graphs are generating here. Okay, maybe in the loop when we use, I think we have to create the file. What I will do, I will be creating a file here, the entire code, whatever we have written, and then we'll explain from here actually. So here we can have a different new file. So I'll be generating signal cosine file name. So I'll be copying here, paste here, then now save the file and run the. There was error, I think extra. We have been generated control X. Let us see. I think the same. Let us try in MATLAB only. I will show you in MATLAB. Default layout. So in the command window or new script file we can create. Just open this. You can see here the values have been generated and the plot also has come. Yeah, this plot is visible. Anyone, can you confirm? Because I have cut the values from 0.2 to this values, right? The whatever the value we have given within that range, it has been. We are not having any value here, right? I hope you are following. So in the next, what I will try to do is I will be filling those values by using the linear interpolation, or spline interpolation, polynomial interpolation. We have various methods. So same plot again we have to do. Fill missing. I'll be taking here. Data preprocessing. So let us try to fill by using the previous command. Now what happened? See, you can see here, right? It has taken the previous values and then it is tried to fill actually. Previously there was no data, right? It is cut actually this values. But it's still, if you feel like some of the model we are getting the better model, then you can go with this. Or if you still you want some smoothness, you can try with a different methods actually. Let us say instead of previous, move mean. Spelling I think wrong. Come up 4 values it is there. Now see the same graph. There was a slight better smoothness, right? I hope you are able to observe. Now, R if you want, I think you might have tried with hold on. I think if you can also have various methods. They have mentioned constant also, right? Let us try with a constant. What will happen? See, because there is a provision for each concept in the respective position only we have to apply. The concept mathematically we define constant const. After the constant, use wrong. I think constant method we have used different. We'll also have some other methods also. No? I think you can try the linear interpolation. You can see here the same. You can search for linear interpolation. Linear interpolation or spline interpolation. All these things you can see. So you can see here interpolation are there. Examples you can go. In simulation actually. Interpolation. Interpolation command. I think spline interpolation, cubic interpolation. Spline is this. You have to use in this way. Only in film missing, right? Film missing. Here only. We have to give the constant value actually. Let us try with that also. In the previous command, we have given constant. We have not given what is the value of that constant value. So that now again plot this. There will be a change in the plot. See, you can see here, right? It has taken only one wherever it is fill missing value are there. Similarly, we can try linear spline interpolation. Linear. Linear, yeah. It has generated the data. Plot of ILTR 1 method. Now you can check it with the plot. See, I think this also somehow better, right? It has smooth curve. If you take spline, I think it become proper actually. It means if you want to have that depends on the model that you are working actually. You have to decide what kind of method that you require and what kind of data also you are looking at. Right? That is the way we can see. There is a spline also here. You can see spline method to generate it now and plot. Now you can see a similar kind of smoothness here. This is one signal. We will also try to see this. This is how like we will be making the smoothing the signal. We'll see here. There is another signal we have smoothing data. I hope it works here. Redesign the signal. Let's move with the MATLAB. So now the plot is, yeah, this is the signal we had. Here also we'll have a cut. So that signal we want to make by redesigning the signal. We want to make it a smooth actually. So for smoothing the data, we have a smooth is a command actually. Smooth data we have used here. Data has been generated. Plot of. We have to plot so that you'll get clarity. Resignal. So if you check with the signal now, somehow it is made a smoothness, right? So this is how you have to design, like you have to decide what kind of method that you are going to use. Depends on the model. Here we have given move mean, right? We can also change here again. Both data, the redesign signal. If you use up and arrow marks, you can get the previous command whatever we have used in MATLAB actually. So I use the linear here instead of both data. Okay. So G1 was not there. Okay, Gaussian. We do not have here linear command. Smoothing we are going to use Gaussian low pass the filters, right? So we can use the Gaussian actually. The smoothing data instead of linear, let us use Gaussian distribution. So if we use the Gaussian distribution, I think it might change here. So this is how one can decide like before processing the data handling stage, one has to take care of distance. So this is about the data handling technique as of now, and I will try to move with the slides. Yes. Yeah, you can also see the mathematical mathematical area, and also the role of that particular concept in where we are going to use exactly in the particular algorithm. Linear algebra is something that we most of the time we represent the data in a data like matrix form. So, and once you know the data, then if you want to model representation, most of the time the linear algebra concepts we are going to use in the predictive analytics. When come back to the probability case, like once you have the model, sometimes we may be not knowing about the model, that uncertainty in the system. This comes under like reinforcement learning, those things. Most of the time, you will be using this. And statistics will give you the inference, statistical inferences values and measures actually. From that, we will validate our results with the existing results. And calculus is something that today what we are working like the machine learning things, right? Once we, as of now we discuss it, right? And when we have a data can be trained at data processing stage. Once the data processing done, then one has to go with the model exploration, learning the model exploration. Once you know the model exploration, then we can go for the prediction. So that is the like the main part is like if you want to update the values and if you want to learn from the data, all these things can be applied in calculus concept only. And numerical methods, as just now we have seen, the computational solutions like sometimes error analysis and the iterative process has come from the numerical methods only, because they are updating the value, right? We are saying update the value from, we will be learning from the numerical methods. And the information theory, this is like efficient learning models. We will be using this, the predictive analytics. And stochastic process, like most of the time these days, without time based. If you have the data related to time based predictions, and this one, seasonal variations, all those things, if you consider, you have to go with the stochastic processing. And another one is the recently the people are working in the PINs actually, physics informed neural networks. That has been like the differential equation. Now people are working with the physics differential equation, then partial differential equation. So that comes with the pins actually. Pins, what it does is it exactly can give the modeling whatever way we are going to do in a numerical method, like simulation kind of model. We can give them and then we can get the solution. And then now we will try to understand in detail about that actually. How linear algebra, how this can be used. As I mentioned, the data and model and transformations, most of the time we use the linear algebra because linear algebra, when you say the word, we will be recalling the vectors and matrices. This most of the time, these things will be in terms of data representations. In computer language, we say that features and observations. And the matrix multiplication stage, like we will be using the model prediction. Sometimes you may be optimized, or sometimes you may be minimized, depends on the model we'll be taking. And eigenvalues and eigenvectors, these are very, very, very important actually. While most any engineer, definitely they are going to use this two things actually, because eigenvalues, eigenvectors, the dimensional reduction means what if PCA is also very, very important actually. Most of the time, the people, those who are working in the image processing, what they do is they may be having the huge data. Sometimes there may be duplicate values also will be available. It is going to high dimension to low dimension. It is going to reduce actually. We also have the method for that actually. We'll be discussing that also. And norms and distance. Norms and distance will help you to design the segregate the values. Like clustering means depends on the model. Like most of the time, reinforcement learning will be using this clustering. There we will be having different values, means different set of values will be grouped into one together. Now we make that particular as some cluster, and different cluster will make, and cluster wise we will be using different activation function, and then we will be predicting the model. So these are the things, as I mentioned, we will be using in the various places. We will see the example also, how principal and what is meant by principal component analysis and why it is required, and where it can be used. PCA is something, as just now I mentioned, that when we have the high dimensional data, that can be converted into low dimensional data. It doesn't preserve on the much information, but only it is going to calculate, take the variance as a measure actually. By taking the variance as a measure, it is going to it is going to take actually the data is like what direction it is mostly varying, and can we represent the data using pure variance. We have a high dimension now, we can able to take the same data in a lower version. Is it possible? This way it is going to train actually PCA. And it is also identify the most feature. Like let us say sometime what happens is the entire things can be represented in a one model without there may be the repetition of the model, the data within the data. So that whole that data can be removed, and which is the having higher most priority, that can also does actually principal component analysis will does these things. And most of the time this will be using in the data visualization model, because data visualization, if you have a repeated values, you'll be getting the there only, right? It's, scattered it at one place, right, in the graph. So that is why, like, to do 3D visualization, they will be using this PCA and pre-processing before regression, as well as neural networks actually. Sometimes you may be having the nice reduction, as we mentioned just now, we have seen, right? When we have a zigzag signal, because we have also, while handling the data, different kinds of signal will be getting. I just have taken only sine and cos. Let us imagine if you are going to take in a different combination of the functions and different variables, then definitely you have highly complex behavior over there. To reduce those noise reductions, PCA is useful actually. And image compression, as I mentioned, like when we have a huge data with a representation in the same way, that can be compressed by using the PCA. And we can also try to recognize the patterns actually from the model by using the PCA. And we can also see some scenario based actually. There is one e-commerce business. They want to analyze the customers, analyze the customers based on age and monthly income and weekly website uses. Because e-commerce business, they are trying to analyze the customers, what kind of age they are and what is their monthly income and how much time they are spending with the website uses. And here the main goal is to reduce the data complexity and identify the dominant behavior patterns and prepare the data for the prediction and recommendation. So this is the data that we have actually. Actually, this have been implemented there in the lab. Let us see here the PCA scenario based. Yeah. So we can check it out here whether it is working. I think it is not generating here. And we will try to go with the MATLAB. See here, I think the entire details solution was there here. See, this is we will try to identify the principal component value with the PCA value with the customer index. So at the end, like what we are trying, we have the initially original data. We have calculated the mean of each feature in the sense. So here, what happens is, what we are doing is like, what was not that every. Okay. I will try to take new script so that we can see here. Yeah, what we have done is here, we are taking the customer data, and with depends on the race and income and usage, website usage. Those values we are and customer data is in terms of rows actually, because I have given here transpose actually. The data will come reverse process actually. Let us, I will remove this semicolon so that you will understand that. See now what is the X value? X is this one actually. Each row is one customer, their age, and this is income in thousands or some lakhs is there, and this is the website usage. So similarly, there are different customers, their ages, and they have given here. From this, we are trying to identify which is least priority, which is highest priority, right? And if you see here, we can also have we also have given some kind of three-dimensional measure here, and each measure each feature we are calculating by taking the center in the sense like average value. From the average, how much distance they have, that we have calculated here. And then we also calculated the covariance matrix, because we want to know like how much importance means. Sometimes we, most of the time, with average as well as how it is varying with the average. If you know, then definitely we can also easily calculate. and eigenvectors and values will give us the how much important the particular customer or particular feature is. So finally the variance has come and PCA has been also has generated here. So with this customer index we can easily identify which is having the least priority, which is having the highest priority. So this is how in the the PCA analysis also most of the time we are using our mathematical concepts like eigenvalues, eigenvectors, and even you can see the networking theory. Most of the time we may be social media influences. How social media influences works actually generally. Like we may be thinking there is no mathematics behind it. There is a mathematics behind every concept. So you can see here there is adjacency matrix in the graph theory. Most of the time we see this adjacency matrix we discuss about, right? Like let us say here I have given you with the detail actually. Otherwise I can show in slide also. Like I can draw pen. See here, I think we are assuming that U1 follows. Just 1 minute, sorry. It's very small. You can see here U1 follows U2 U3. That means wherever that particular, like there is a link, there is a connection from the particular person to particular person. If there is a connection, we will take 1. If there is no connection, then we'll be mentioning a 0. So if you look at that in that perspective, U1 follows U2 U3 means like here you'll be having this side also U1 U2 U3 U4. I think you might be not understanding this. I will try to show you with the. Is you are able to follow, or can I show with writing in a pad? Anyone can you confirm? Like whether all are sleeping?
Yes, sir.
Pad or this one more? Okay, no. Okay, if you are able to follow, fine. Actually, U1 follows U2 means there is a connection from U1 to U2. That is why this side also you will have 4 U1, U2, U3, U4. How many, like depends on user, how many users you have. Similarly, in the column wise also you have U1, U2, U3, U4. Now, if you say like U1 follows only U2, U3 means anyone doesn't follow themselves, right? So that is why most of the time you see the particular place most of the time will be having 0. So now U1 does not follow himself, so you'll be having 0, and U1 follows U2, U3. So there is a connection from U1 to U2 and U1 to U3. So we are getting some value here. So that we have represented here, like this one actually. Later, yeah. So this, if there is a connection, you'll be getting 1. If there is no connection, then you'll not get. So here also you have U1, U2, U3, U4. The corresponding matrix only you'll be getting. And and next we are saying U2 follows U3. That means in the second row, you can see for U2 does not follow U1. The corresponding position we have U1 here. In this place we have U1. Yeah, here also you have U1, U2, U3, U4. So it follows only U3, right? U2 follows only U3. That's why we are having only 1 here. And similarly, U3 follows U4. So on rest of the places you are having 0. U3 follows U4. So you'll be getting 1 here. U4 follows no one. So that is why the entire value will become 0. Row becomes 0. So here clearly we mentioned here rows is nothing but who's following others, and column is nothing but who's being followed. And now we will be calculating the rank. Rank we know already, right? Depends on the rank. We can say many things like how many linearly independent vectors we have. So that way we will be say. But here the same perspective, if you see here the rank tells us that value. The rank is 3 because 3 independent paths are there. What are they? Like U1 to U2, U2 to U3, and U3 to U4. So this is how the path has been designed, and you can see here more independent followers or influences. high rank, which is having high rank. You can see the U1 has most, right? Like two most important. There are two followers are there compared to rest of them, right? So higher rank is for U1, and the lower rank also we can calculate in the similar version. Depends on, right? Similar application, you can also look at that vector. There was a who to follow. There was a model actually. That also you can just. And there is another equation like linear system of equations. Most of the time, the electrical engineering circuit analysis they will be using actually. The same way, I think most of the time we will be discussing this particular example as part of the application. But we were not aware like how exactly implementation happens, right? Now you can see here that when we have a system of equation, we are representing in a matrix form, and we will be calculating the ranks. Depends on the rank, you can say, and we can also calculate the resistance values and the intensity values, right? And if there is a solution, then we can able to solve the system. The circuit can exist actually. Otherwise, no, right? Similarly, the linear transformations that also will be used in cryptography, image processing, and facial recognition. And these are some of the examples. Because I'm here, think that due to the time constraint, I will move faster actually a little. I have to cover many more. So here we have encryption and decryption both the ways. One can do the encryption and decryption. You can see here we have some matrix here K. So we'll be calculating determinant of that value. So if it is getting 0, then we cannot convert that, right? Cannot encrypt that. If it is not getting 0, only if there is an invertible matrix, then K is invertible, then only we can encrypt that. So now the plain text, this is the matrix that we have original system. Now I want to some message I have to send like hi. There is a hi. Hi in code actually from 0 to, if you arrange A as a 0, B as a 1, and so on. Hi we will be getting H as a 7 and I as a 8, and this will be multiplied with this. P is equal to K into P. If the original matrix, invertible matrix, we multiply, we will be getting ciphertext vector actually. So that vector again, if you have to, this is encryption actually. Encryption matrix is C is equal to 4554. Now again, if you do the decryption process, means again we have to get back to the same position, right? Now if you try to decrypt, because C is equal to K into P we have written. Now original matrix is P, we have it, right? So let us take P. P is equal to, we will be getting K. If you take other side K, K inverse into C. So we have to calculate the inverse matrix. When you calculate that, we will be getting again original matrix recovered, right? The same way. So this is how the encryption and decryption process also. Most of the time, our mathematical matrix algebra and mathematical multiplication, they may be using. These are some of the simple examples that I'm trying to give you. The just glimpse actually. And Cayley-Hamilton theorem also. Most of the time, robotics and control systems we will be using. You can see this. And the stability of the drone is addressed by examining the eigenvalues of the matrix. Because as you know, eigenvalues and eigenvectors will give us the priority, the importance of the particular in the drone, like whatever the direction, which direction we have most priority. These things can be easily calculated when you calculate eigenvalues and eigenvectors. So you can also see, like we can confirm, like if all eigenvalues are negative real parts, then the system is stable. That means the drone eventually return to the stable position. Otherwise, if the positive real parts we have, the system is unstable, the drone will be uncontrollable actually. So this is how the stability of the drone also we can calculate by using the eigenvalues and eigenvalues. This is the way you can see, like these are the general system that we have given as a drone system. If you take the corresponding position only, we have the values, and rest of the places will doesn't have 0, 0. And if you process the data by using the Cayley-Hamilton theorem, we will be processing and we will be getting this. I'm not doing any calculations. I think at the end we'll be getting that whether the system is stable or not. as by depending on the three conditions. All eigenvalues, if you get negative, then we say that the stable system. If it is not getting, then unstable system, then one has to taken care, right? They have to reassemble the things. And similarly, the canonical forms also, we will be using most of the time dimensionality reduction, PCA. That is like most of the time reinforcement learning. Also, they use this canonical forms and mathematical description of PCA. The data representation will be in this way, and we will be calculating. Centering means that average value will be calculating, and after that we will be calculating the covariance matrix. With respect to covariance, we will be calculating eigenvalues, eigenvectors. So that once you calculate this, only we will get to know that this particular value, this is high prioritized value, and also for the particular system, a particular direction also. We can easily get to know from this. This is some of the examples one can see here. The decomposition also I can, decomposition method as I mentioned, PC also the decomposition methods we have, right? Singular value decomposition, SVD. So this SVD, the most of the time, like as if you are working with image processing, definitely they might be using this because they want to decompose the higher dimension system into the lower dimension system, and then they will be processing the image. And they can also use in the various recommendation systems also, and even noise reduction also, because noise reduction, if you have zigzag signals, whatever we have, the image or whatever, that can be converted into data. That whatever the repeated data and unrelated data, they can remove and then they can process actually. Nice. And this is the method. I think singular value decomposition. I'm not explaining this actually. Singular value, because the A matrix can be composed into three matrices, right? After that, again, we'll be getting the same similar matrix. The same matrix can be, they are decomposing into three parts. That means the three parts, when we have that, we can able to do in single matrix. That's what the meaning, right? So the same way we can do that actually. So this is the calculation of singular value decomposition. And inner product space, as we know, inner product space will be used in as a support vector machine algorithm, normalizing and path optimization also in the robotics. And filtering also, noise filtering also, one can use this. And probability theory, like as we mentioned, the uncertainty modeling, right here. Statistical inference, decision making models. In the decision making model, the main high priority is this. You might be knowing about this one, right? Like a confusion matrix. Actually, what happens is in the disease modeling, sometime because we may be using the testing of hypothesis mostly there. We are using the testing of hypothesis, but here what they do is in the testing of hypothesis, the overall decision will come usually with respect to if you take any particular data. Because when you see the scanning report, what they say, the overall result, they say that this is the situation. But when you have the confusion matrix, one can say that exactly in what condition it has predicted wrong and what condition it has predicted negative and positive. So these things one can get to know when you calculate the confidence confusion matrix. So this is how the statistical inference also and hypothesis testing also will help us in deciding the decision making process effectively. And then the calculus, as we mentioned, the same like calculus also, when you say the calculus, the first thing that we see is the regression. So we have to fit so that the C and theta values, so that the closer, so we'll be getting the accurate value, right? The error will be lesser. So, and we can see here some of the scattered data has been plotted here, different sales and different sales and marketing, how much they have spent in dependent and independent variables, and you can see how they are scattered. Like if you try to draw a line, because there is no line that covers all the points, right? Like straight line. So that is why we cannot able to divide this part into the clusters. It's our classification models. You have to plot in a different lines. As you can see in the next line, there are different lines we have trying to cover all these points, right? So this is the kind of model, because these are highly nonlinear models. Make this linear because one has to move with some of the model, and they have to go with the model exploration. Then they go for the prediction. And the cost function, this is the cost function as we see most of the time 1 by n into y minus y prediction, right? This actually the least square principle. We will be studying as a least square principle. The same least square principle today, they are calling as a cost function or mean squared error. Like we can also say mean squared error, right? We'll be calculating the mean square error. So that based on that particular concept, whatever we see, the gradient descent or gradient ascent algorithms, gradient descent only we have seen because most of the time because descent in the sense it is going to reduce the errors, in the minimizing, in the sense like the curve will be the negative directions. But whereas in gradient ascent model, we will be updating, we will be taking the plus actually. But where here they will be getting negative value, so that how much closer they have come, so that the error will reduce, right? So that will be calculating here, and we can also derive these things actually. Like wanted to do before going to that, we will try to derive the gradient descent algorithm. I think is it okay? Still, how much time I have so that I can plan my presentation? Organizers, can you repeat and can you tell someone?
Sir, max 10 minutes you can continue, sir. Still another 10 minutes. By 1:15 session has to conclude. So that at least 1:05 or 1:10 you can finish.
Okay, fine. Thank you. I'll show that. I'll finish it. So here, what we are trying to do is in the cost function, y mx plus mx plus c whole square we have right here. The so if you differentiate this one with respect to m one time, dou by dou m with respect to m, if you do, let us assume this as a Jacobian j something. Now if you assume j and if you differentiate with respect to m, we will be getting one cost function because updating the values, right? And with respect to c also, we will be getting one function. So parallelly, each iteration, the values will reduce so that the c and m values almost approaches to the closer, then the error will be less. So that's how we derive actually. As like I have many things to discuss more, I think we just move. I think in the other two lectures they have been covered, I think, right? Gradient descent. So I will be skipping. Then you can see this activation functions. In the neural networks, we are using directly the neural networks, right? The background behind the neural networks, there is a lot of activation functions actually. And another important thing is we are confusing with activation function. Means there is a new word they have been generated. It is not nothing new. Activation, whatever we use the functions, right? The function behavior only they are considering as activation functions here. We know exponential function, we know sine wave function. So this we know the step function, unit step function. The same function, the behavior only depending on the behavior they have divided the models. So only thing is once you want to aware of the things, because earlier in the initial days they are taking the right now they are considering only the different plots like straight line. Like we'll maybe having the step function so that it is going to divide the classification algorithm that way. But if you see, if you look at now the recent days, whatever they develop, they are the combination of the models actually. Like when you say the tan function, you'll be having the combination, right? Tan hyperbolic also will have a combination, tan combination and cos combination. Because early days they are not having the awareness of these particular functions, and then day by day they are developing. Now one can take what they can do. They can have a combination of the functions so that it is going to get a different kind of function. I'll show you the plots also so that you will have a clarity on that. So here I think these are the input values. Generally, what happens is while calculating the ANN, even if you train in the model also I will show you at the end if possible. One ANN model. If you just dump the data, it is going to train the model and then it is going to final output. We don't know what is happening behind that actually. So this is the main behavior that is going to happen actually. So it is going to generate the different layers in between. So that also depends on the data that we are giving, what output that we are expecting. Depending on that, it is going to generate different layers here. So now you can see x1, x2, x3 as xm. There are some input values are there, and their weights also there. I have given w1, w2, w3, wm. They are weights of the particular input values. Now I want to calculate the next value. Like let us say these are xj values. If you want to calculate in the next stage, right? Overall, the output is yj. We have to calculate yj. Before that, we may be having the internally there are different layers. So for each layer, the same behavior, whatever we discuss here, the similar way it is going to work out actually. So what they do is here, you can see here x1, if you want to calculate this value, right? I can say, I think if you want to calculate this, here, this particular node value, got xj, let us say, we are taking x1 into on particular weight, because this is linked with this. So x1 into particular weight plus x2 into w2j plus x3 into w3j and so on, still xm into wmj. So this is the way, because these all are connected with this particular layer, this particular node, right? So that is why we will be taking all these weights, corresponding weights with the corresponding input values, so that we will be getting this. Once you get this, then it is easy to get, right? Because yi is overall here, if you have xj, yj is nothing but f of xj that we defined here, right? So yj is nothing but whatever the input that values we are getting here, that values will be substituting here. So this is how the inbuilt, like in the neural network in background, it works actually, right? And you can see in the next slide, you can see this is the commonly they used functions, activation functions. You may be heard about in the earlier lectures. Step function. Step function is not new for us actually, right? It is well known for us for a longer time. Why, how they are using? You see here, step function. Usually, this is the behavior actually, right? Step function. For a positive value, it is going to in a positive direction. For a negative values, it is working with a zero negative direction, right? So what finally they conclude is like whatever the hidden layer, like you see, this is the, they say like step function as activation function, but for our their model, they say that classification model they use step function. Because what happens is here, sometimes the data, when you're handling the data, right, you may be getting this part and you may be getting this part, because the data has been divided into two parts. So that's the same thing, only the classification, because we are using the classification algorithm as a inbuilt, actually the activation function will work, but here we are going to get in terms of classification model. Similarly, there are various classification models are there. It is depends on the behavior. Now again, see, our requirement is from 0 to 1 means in 0 to 1 values, and then means 0 to 1 it has to divide. What kind of function that we use? So this is the way you are going to use in step function. Next, if you sign function, sigmoid function, what it does is, for negative value you'll be getting -1, for positive value you're getting 1. That means here possibility range is -1 to 1. Suppose you want to design a model that has to be start with the -1, positive direction is one side and negative side one direction. This is also the classification model, because when you divide the data, sometimes you may be getting here from one positive side and negative side. So indirectly we have to understand this activation function is nothing but indirectly we are doing the clustering, we are applying the clustering, we are doing the classification, we are using all kinds of algorithms here. And this is a linear function. Linear function is generally we use for the regression model, whatever we discussed, right? Regression is going to whatever the gradient descent, gradient ascent. Gradient ascent will be used in finance models actually, because they are highly they require more betterment values. So ascent model will use there. And whereas in other cases, we will be most of the time we use gradient descent in the research analysis. And this is the rectified ReLU function. They say the ReLU function, the behavior of the ReLU function is this. Suppose if any function, like any model, the data that we want to have this kind of model, because here this is the one classification and this is another classification. The overall 4 data, right, is divided here 2 parts and here also 2 parts. So that way, if you want to have that kind of data, then they will be using ReLU function. This all the things has to be learned from the data. The data only it will learn, and then it is going to give us the positive like values. And this has a hyperbolic tangent function, as you mentioned. It is a combination of the model, right? Initially we started with the sigmoid function as e power z and exponential function. This is the function that it is going to cover the in between the origin with the entire region, right? So that is why it is dividing the entire region into two parts. So this is also useful for the classification, because this entire side is one part. Let's say this region entire, no sorry, before above this part is one classification, below this is one classification. That's how we are saying -1 to 1 as outputs. So this is how they are using the classification models. And most of the time they will be using this actually sigmoid function, the powerful function. So this also use the entire region into two parts as mentioned here. And sometimes suppose you may be having the perceptron and neutron. You say that there is a concept called multi-perceptron and single perceptron also. That is very simple actually. You'll understand easily. And here there may be some oranges and apples data we have, because images we have. Now you have to classify this. All apples should go in the positive side. Let us say this side. All oranges should come here. That are related. So it has to classify in the similar way. To do that, sometimes you may be using different kinds of function. Here, sigmoid function also will be helpful for the classification model. No need that we have to use only for the apple and orange classification. We have to sigmoid. We are giving the example. We are showing you the example that how the classification can be used. This is the one of the classification to better understanding. And this like binary classification, and we also have implemented here. You can see here we have different ages and different have whether they are taking the insurance or not. If they are taking insurance, we'll be making a 1, and if we are not taking the insurance, we'll be taking a 0. So by using that, one can by knowing this huge data, what they have to train this model, and then they say that this particular age if you give, whether this person is going to take or not. That way they have to decide the insurance person whether the person is going to buy insurance or not. So that's how, because they have mentioned here, that means they see 0.5. If you are getting less than, then you will not going to buy the insurance. If it is greater than that, you will buy the insurance. Now because from the model it predicted, this is the equation actually, right? From this equation, now we are replacing this x values. X values is not ages actually. Ages, if different ages, if you substitute here, so that depend whatever the value you are getting here, right? Here for the age 35, you are getting the 0.48 as a value. That means this person is not going to buy the insurance. If it's going to, like, if you similar way, if you want to check different values, you can check it actually. Substitute different values so that we can get to know that whether the person is going to buy or not buy. Right? And this is the multi-layer perception actually. Different weights, different ages will be there. We'll be taking that and then we'll be calculating. This is B as a bias actually. Don't get confused here. B as a bias number, like y is equal to mx plus c. We say that x c, right? A similar way, the bias actually. And now here, like the same way, like we have different ages and education, income, and savings. That depends on that also. Sometimes we may be trying to predict that the person will buy insurance or not. Also can be done. Yeah, this is single perceptron means here with only single layer if you use, that is single perception. Perceptron actually, perceptron. Now if you see here, there are the different layers. Again, there is one more layer. If it has, then say that multi-layer perceptron model. I hope you understand this, right? Means you can see here there are here one cluster is required, and this what one cluster is required, right? To divide, and these two are same and these two are similar, right? So this is the way when if you want to divide, like the multi-layer perceptron model, because it depends on the data it is going to train and it is going to give us actually simple. And here also we are able to separable, like you can see here, right? This is one data and this is one related data. They are together, right? So that's how it works actually. And here activation function concept is same. Like let us suppose if you want to calculate this, you see this particular link, this one plus and this one multiply x1 into this particular weight, x1 into this particular weight. And similarly, if you want to calculate this, you have to see the links actually from where to where it has a link. That's all. And then you'll be in the internally also the same concept will apply again. If you have multiple layer, similar concept will work out and then it is going to give us the values. And you can also see sometimes it may require only the one classification, one line is enough to classify the things. Sometimes you may require multiple lines to draw the separate the things, like separable things. And here you cannot do anything, right? It is it's tough. And here also you can see somehow we can do, but it is tough actually, right? This is weight calculation in multi-layer perceptron model. I think the similar concept will work out. Actually, you can see here. If you want, I think I can share this slide so that you can go through that actually. Because this weight, because in the ANN, what happens in the MATLAB or whatever, wherever you do, if you are working in the even Python also, we are just using the libraries. We are not implementing all these things. So this is inbuilt function, like how mathematically, like we are designed, like mathematically how much like mathematics concept that they are using, that you should know actually, right? Then this is how the calculation will happen. Weight calculations. Each layer is going to calculate. You can see here, right? F of x means this particular x1 into particular weight, and this is linked with this also. So x2 also has this link with this one, right? X2 with w, because the particular weight is w14. That's why we are taking here plus bias 1. Similarly, h12 if you want to calculate h11, h12 if you want to calculate the particular, you can see here h12 if you are calculating. We are having x1. X1 was corresponding weight is x1 with w12, because the second one h12 is here, right? So then similarly from here x2 to there is a connection. So w15, x2 to x2 into w15. Similarly, we will be getting multi-layer perceptron model. This is how we have to calculate the weights, and then we have to substitute. This is how the layer has been decided, because we are just going to select in a MATLAB with one single drop box. But internally there is a lot of things that are going to happen actually. You should know. And this also the model. Yeah, I think back propagation and forward and pass. I think they have other speakers has explained about this actually, right? I think back propagation means you'll be getting this same way calculations are done actually, similar version. These are updated values. You'll be taking different values till you get your accurate value, right? Forward pass also will be using the same the sigmoid function till you get, you'll be using. And these are different functions that we already know, I think, right? From the other speakers, you might be knowing these functions. And the only thing is you should know the what kind of behavior that follows. With that behavior only they are dividing, classification, clustering, all these things comes with only the function behavior. They are not new words or nothing new. And sometimes they maybe use the combination of functions. You can see here they are the soft plus will come a combination of logarithmic plus exponential function. You can see here tan function with log and exponential. They're calling a mixed function. Means this is how they are deriving the models actually. So it is very like once you understand the things, it is easy. If you are not understanding, you feel that it is very new. And this is the general mechanism as already shown. I think cost function and gradient descent. I think this is from the last. I think learning rate also should be like most of the time 0.01 they will be taking. If you are not taking the proper learning rate, it takes longer time, and it is also takes some time data exploitation, field to convergence also. Overfitting and underfitting and fitting. Exactly, it is covered right. And then only say that it is affecting the property. And the linear regression, when you substitute there, you'll be getting. And these are some of the information theory. There you are going to use entropy, cross entropy loss, and KL divergence and mutual information. So these concepts will be used in the classification and deep learning processes mostly feature attraction, feature selection model. And in the Markov model and random walks and time series models, forecasting, and most of the time finance model and climate and biological studies also, because they are time dependent, right? And seasonal variation also will come. So that is why we will be using this. And differential equations, as I mentioned, physics informed neural net, this is a trending now. Most of the time they will be using this. Actually, right as of now, I just want to show something. Before going to the next generation research, I just want to show something. Over time, 15 already over. Can I show something in the MATLAB, or organizers has to respond now?
Sir?
So that I wanted to show something on the MATLAB, like ANN model. Is it okay?
Yes, sir. You can take another
Just
5
simple.
minutes, sir. Yes, sir. Yes, sir. Please, because many participants are very much interested. You can take,
Okay.
sir.
Okay, thank you. Now, what I will try to do is I will show you in the MATLAB. As of now, we have discussed with the various inbuilt multi-perceptron and all, right. In the ANN, it's simple. There are the apps actually. In the MATLAB, if you go, there is a command called apps. There are various commands here. Classification learner. Classification learner means the data, if you give the classification related data, automatically it is learned and it is going to give us. And deep network designer. So all these learners are there. I will just going to use this one, classification learner, or any other model also. Similarly, you can use all the apps actually. Their classification only we have sigmoid function. It is going to classify, right? Just use in the background. But here there are different classification algorithms. That is very important to understand actually. What kind of classification algorithm we have to use? Sorry, I think here we have to upload actually. No? From the file we have to upload the data. I have some data that is collected. Let us see. For the classification, the model. Suppose if you are working with the fluid dynamics, what you can do, if you have a classification, right, various kind of classification, like nano, hybrid nano, you may be saying like suction, injection, you are saying that data should be segregated properly, right? Because if you do that properly, then definitely the classification may happen. I think here I have Spotify data set was there. I think it depends on the audioness and some visibleness we will be taking actually. Let's see here. When you import the data, because you no need to do anything coding actually here. If you want to do coding, that is also there. Like maybe we can use it actually. And another beauty is in the MATLAB, once you train the model, if you want to code of that particular model, it is easily come here. You can generate the code also easily. You can re-edit actually. So import selection. If you import selection, then it is going to ask you, suppose what you want to predict actually. Like we will be taking releasing date as something, tempo as a response values. Response values are here, so automatically that's why that is not showing there. Okay, let us try with the tempo values we have to predict by knowing all these values actually, right? If suppose if you want to feel like these are not input values or output values, then you can just make a tick mark so that particular will not that will not come into the like training model actually. So once you select this, just start session. So it is giving us some here, and simple is like here you can see in the right side there is a linear relationship between these two actually, right? Track ID, track name, but these are not useful actually. They have to use a different let us say energy with respect to some loudness. So how these are scattered, see here, almost I think there are a little closeness somehow, some values, because as you more loudness happens, then automatically we lose some energy, right? Loudness. So that way, like you may be having, and now you see the algorithm that we discussed, all the things can be done within one click. Just here click on train all, automatically it will give us. I think it will take some time. I will go with the quick train. And PC also there, you can see here, as we mentioned, the principal component analysis, which is high priority. So that those things also can be done actually. Feature selection, after measures. It is taking time. Yeah, I think. Oh, 12 of. Oh, sorry, I think. No, it is there. MATLAB. The apps actually, I think we have started classification learner actually. Classification learner. Yes. We'll upload the data from the file. I have here presidency. quantify data. So we will import the selection. So as the tempo is a output response value and result input values, start the session. Okay, it is giving you the summary. Like initially the maximum number of states is 100. You can also see PC are disabled here right now. You can, if you want to enable, you can enable also. If you want to fix the variance, you can also fix here in some percentage. If you want, you can fix with this. And the scatter plot also we have, but we need with energy with other parameter, because initially they are scattered in this way, some other value, and now you can train the models and then you can check actually. I'll click on this quick train so that it will make it faster. So after training, then you can go with this. Which you can see with respect to each value how they are scattered within the graph, right? Depends on the value whatever we are giving, the features, so that is going to train herself actually. I'll quick train happening. And now it is saying like this model does not have a hyperparameter option, means hyperparameter does not have actually. So when we find, I think try now. Should try. So you can see the various algorithm, KN and tree. These are clusterings actually, right? They are going to segregate the things. Depends on the what, like you can see here. And you can have mostly scattered plot and confusion matrix. How many positively reflected with respect to each parameter also we can see here in the confusion matrix. See here, there are number of observations we can see here. How many true positive rates are there, false negative rates are there. Meaning like true positive rate means if there is a, suppose that the person is having the disease and the process also has predicted he has a disease. Sometimes what happen if the result is false, but the report is negative, means opposite, then that time also that is also wrong, right? Because these two are very dangerous actually. Positive, like false negative and false. No, sorry. True negative and false negative. These are very important, right? They're very dangerous results actually. You can check here with respect to each data it is going to give us. But in the generally in the scanning report and all, we'll be getting directly the value. They say that you don't have a disease, you do not have corona, you do not have viral fever. This is the way they'll say, right? But here in the confusion matrix, we can get to know easily. Like with respect to each data, you can get to know. Here there is a tree also. PC is enabled. If you want to enable PC, you can also enable PC. I think you can also use different optimizers also we have here. And as I mentioned, if you want to code, right, this generate function export model. In this is, if you want to have that model, you can also have this. There are the Bayesian optimization. The different optimizers are there, so that you can get to know that what kind of optimizer I have to use. These things are there. You can save apply. Now, if you see this plot, there are more options here. You can also see heuristic or validation if you want to see this. And also we can export this model, export plot data. You can also have this data. The data will also will come if you want to have in other software. If you want to use, you can also see default model and results table. So accuracy is 0%. Validation is total cost we are getting. Okay. There are different algorithms. These are actually trained. And if you want to change this results into the plot option, you can also see there are various options here. Export to model to workspace, like direct. If you do not want to save directly, you can export this so that it will come to the workspace actually. From there, you can directly open actually. classification, comparative results. Yeah, I think let us move the slides. And as this is the last phase, actually, next generation research. So the early days, as we know, the most of the researchers, right, what they are doing, like the title is like the default title is next generation research, right, with respect to mathematics, we say. But here in the initial days, the authors are accessing the articles by going through the libraries. And later stage, mid-level researchers, like you can see here, they used to go there and they used to take the print and they had to get the Xerox copies and then they used to do. But now in the mid-level researchers, now databases has come, online journals, right? So in this is the way we are online journals they're getting, and then that's the different databases we are getting. From there you are learning. But in the next generation research, it is a very dangerous generation. They are completely depends on the computational intelligence. We are not trusting ourselves. We are just only the dependent on the computational intelligence. So because things are changing in that direction, so people also moving in this direction. And then I want to conclude, like the overall, without mathematics, nothing, no engineering actually. You can also see that. And these are the reference I have taken from the all AI tools only. This reference, whatever the sources that I have been presented today, because I am also the part of the next generation research, so I wanted to use those type of things. And I want to conclude, engineering plus math is equal to everything, and engineering math nothing. So thanks for the organizers once again for giving me the opportunity to share my views on next generation research. Any questions?
Participants, kindly unmute yourself and you can ask if you have any queries.
Hello, sir. Good afternoon, sir.
Good afternoon.
Sir, I want to learn the basic things, means which books I can refer, sir. Which are the books I can refer? I want to for machine learning, sir, for regression analysis.
You can go with this one, madam. Hilbert's calculus. Linear
Okay, sir.
algebra. And if you want to for calculus, applied numerical method by Chapra.
Okay, Chapra.
It was a very good book actually. Applied numerical methods by I think Chapra, madam.
Okay, sir. Thank you, sir. Thank you very much. Okay, sir.
The problem is they have not mentioned the detail, but only thing they have to learn from the different sources. The books also they will not write in, with the detail.
Okay. I will go through that, sir. Yes. Thank you. Thank you very much.
Participants, any queries?
Sir, good afternoon, sir.
Good afternoon, sir.
Sir, could you suggest any Google links for audio listening of these type of basic things, sir?
Google, sorry, sir.
Sir?
Google links, in the sense like.
Could you suggest any YouTube links for basic information?
Sir, you can see the Kaggle website and sklearn website, sir. And these are the website where you can learn easily these things. But there, in terms of library, not as a function like with the detail. But you have one course on SWAYAM, sir. A to Z neural networks. There was one course. Not right now. I think it is not running. But earlier it was running actually. In the SWAYAM.
Okay.
That multi-perceptron, whatever I have given, right? That is from the NPTEL only actually. NPTEL notes. So there was one professor, he has explained very well. IIT Roorkee professor. I could not remember exactly the name, but he explained very well how neural networks.
That video is available in website, sir.
Which one, sir?